Alright guys, today we're going to work on factoring special products, and these are two things that we've already seen. So the first one is the difference of two squares pattern. Now notice, a squared minus is a difference, b squared. You have two perfect squares, and they're separated by a subtraction. It factors into a plus b times a minus b. So on number one here, y squared is a perfect squared. Y times y. 9 is a perfect square. 3 times 3. So when we go to factor this, I'm going to write out our factors as y plus 3 and y minus 3. Notice, y times y is y squared. 3 times negative 3 is negative 9. 3y minus 3y is 0y, and there are no y terms there. This is how you factor a difference of perfect squares. So, try number 2. Notice there is no GCF, so there are perfect squares. Try to factor them. When you're ready, turn the video on. Alright, hopefully you're ready. You saw that 4 would be 2 times 2, and 25 would be 5 times 5, which would give us 2x plus 5 times 2x minus 5. Difference of perfect squares always follow this pattern. You're going to have to memorize it. Alright, number 3. We still check for a GCF. Now, you might say, well, they're already perfect squares, and they are. But remember, we always need to make sure there's not a GCF so we can completely factor. So 64 and 16 are both divisible by 16. And that leaves us with 4p squared minus 1. Well, 4 and 1 are still perfect squares. So when we factor this, we're going to put 2p, 2p. We have a plus and a minus. It doesn't matter which goes where. And then 1 would be 1 times 1. This would be the complete factorization of 64p squared minus 16. So try number 4. 225 x squared minus 144. This one does have a GCF, so try it, and then when you're ready, turn the video back on. Alright, hopefully you found that the GCF is 9. So 9 times 25x squared minus 16. 25 and 16 are both perfect squares. It is separated by a subtraction. It's a difference. So 9 times 5x plus 4 times 5x minus 4 is the correct factorization. Alright, number 5. 49 minus 121p squared. Now, this is not in the correct order. So that's the first thing we need to do, is put this in the correct order. Next thing we do is look for a GCF. Well, the only thing they have in common is a 1, but the first term is negative, so we need to factor it out. This gives us a difference of perfect squares. 121 would be 11 times 11, 49 is 7 times 7. So when we factor this, 11, 11, we both have p's, plus, minus, 7, 7. It does not matter which one you give the plus and which one the minus, as long as you have one with a plus and one with a minus. Alright, number 6. Negative 3m squared plus 48m squared. So, we're still looking for a GCF. They both have a negative 3 in common, leaving us with m squared minus 16 n squared. Now, don't freak out because there's two variables. Notice they're both perfect squares. This is a difference. 16 is a perfect square, so we can factor this as m times m plus minus, and then that would be 4n and 4n. And if we check it, notice 4mn minus 4mn is 0. M times m is m squared. 4n times negative 4n is negative 16n squared. This is the correct factorization. Now, important note, this is only for differences. If it has a plus in the middle, you cannot factor it except for the GCF. So if this was 4x squared plus 25, you would leave it alone. It doesn't factor anymore. Alright, next thing is our perfect square trinomials. We've actually already been doing this, okay? The only difference now is the notation at the end. Okay, we've seen this in a homework problem. So we factor them the same way. Look for a GCF. There isn't one. So we're going to write our factors. X squared is x times x. Because the second sign is a plus, they're the same sign. And then we're going to look at the front sign, and they're both pluses. Here's where it's a little different. Because 9 is a perfect square, that's a good place to start. Okay, always start with your perfect squares because a lot of times that's going to be the correct factorization. So when I check 3 and 3, I end up with 3x plus 3x, which is 6x. So this does work. These are the exact same factors, so our final answer is written with a square on it. Final answer is x plus 3 squared. So number 2, 2y squared minus 20y plus 50. First thing we do is find our GCF, and there is one, 2. So y squared minus 10y plus 25. Okay, always be thinking ahead. Y squared and 25 are perfect squares, so when we factor this, that's where we're going to start. Y and y, they are both minus signs. And I'm going to start with 5 and 5. Hopefully it'll work. Negative 5y, negative 5y. That's negative 10y. It does work. And then all we have to do is rewrite our answer with a square because that's the simplest way of writing it. So number 3, I'll let you try number 3. 49x squared plus 14x plus 1. Quick note, 49 and 1 are perfect squares, so that's where you should probably start. I'm going to give you a second, pause the video. When you're ready, turn it back on. Alright, hopefully you're ready to check your answer. 49 and 1 are perfect squares, so 49 would factor into 7x and 7x. 1 would be 1 and 1. Notice they're the exact same, so 7x plus 1 squared. So not much different from what we've been doing, it's just now there's a different way of writing it if it's the exact same. So our two different versions, difference of two squares, perfect square trinomials. Now we're going to actually solve. So on number 1, 16x squared minus 8x plus 1, the only difference is it has an equal 0, so we have to finish the problem. So there isn't a GCF. So just like a normal trinomial, I'm going to try to solve this. However, I notice 16 and 1 are perfect squares. So when I start checking my factors, that's where I'm going to check. And let's look. Negative 4x is negative 8x. I knew they were both minuses because same sign, positive. They're both negatives. We would not write this as two separate factors. We might write it like that. Now if you forget this step on solving, it's not a huge deal. Just don't do it twice. It's too much work. Just write it once. 4x minus 1 equals 0. You can solve it twice if you want. 4x equals 1. So x is 1/4. If you get the same answer twice, don't write it twice. Just write it once. There's no need. So this one only has one answer. So number 2, first thing we do is look for a GCF. It's got two terms. So 4 goes into both of those, and we're left with x squared minus 9 equals 0. Now, x squared minus 9 is one of our special products. It's a difference of perfect squares. So that's how we need to factor it. X plus minus 3 and 3, different factors. X plus 3 equals 0, x minus 3 equals 0. So x equals negative 3 or positive 3. You might also see this written as plus or minus 3. Either way works for me. Doesn't matter which way you write it as long as you have both answers down there. Alright, number 3. This one's got some nasty fractions, but we know how to get rid of fractions. All we have to do is write the least common denominator and multiply everything by it. So 3 and 9, we would have to multiply everything by 9 to get rid of all the fractions. So when I do that, I end up with 9x squared plus 6x, be careful there, plus 1 equals 0. Now there isn't a GCF, the 1 kind of gives it away. I do notice that 9 and 1 are perfect squares, so that's where I'm going to start. 3x and 3x, both of them are pluses. 1 and 1, always go back and make sure it works though. 3x plus 3x is 6x. So 3x plus 1 squared equals 0. So then 3x plus 1 equals 0. So x equals negative 1/3. One answer on that one. Okay? Alright, next, our lovely word problems, which we all love. So, while standing on a ladder, you drop a paintbrush from a height of 25 feet. After how many seconds does the paintbrush land on the ground? This has to do with our formula. H equals negative 16t squared plus vt plus s. Now, we want to know when it lands on the ground. So that's our ending height, 0. We don't know the time. They say, how many seconds? Seconds is time. Now our velocity, notice they don't tell us the velocity, but they tell us that we drop the paintbrush. Okay, we're not throwing the paintbrush. We're not kicking the paintbrush. We're dropping it. So anytime you see the word drop, that means the velocity is 0. There was no force put behind it. It just fell. So we're going to put plus 0t. The starting height is 25 feet. Okay, so now let's rewrite this without 0t because we know 0t doesn't really need to be there. We're going to factor, so find our GCF. In this case, it's just a negative 1. So 16t squared minus 25. Notice these are difference of perfect squares. So when I factor, 0 equals negative, we're going to have 4t and 4t plus minus 5 and 5. Check it. 20t minus 20t is 0. 4t times 4t is 16t. 5 times 5 is 25. So now, either 4t plus 5 equals 0, 4t minus 5 equals 0. So either t equals negative 5/4 or it equals positive 5/4. Now, which one of those makes sense here? Can't have negative time, so we would say 5/4, and it would probably be better to use this as a decimal, so 1.25 seconds. Now, if you leave it as a fraction, it's not a huge deal, but 1 1/4 seconds makes a little more sense. So I want you to try number 5. Pause the video now. When you're ready, turn it back on. Alright, so hopefully you started with your formula. Because the hickory nut is falling from a branch, it's not the tree's not throwing the hickory nut. So there's a 0 velocity there. The height is 100 feet. So that's how high it's up. So we fill in our formula. Okay. Notice I put up the GCF of negative 4. It made my factoring much easier. Now if you didn't do this, it probably didn't change your answer, but we want to practice good factoring. So our factors are 2t plus 5 and 2t minus 5. This is a difference of perfect squares. You need to be able to recognize that. When I get my answers over here, I get negative 5/2 and 5/2. Okay, negative 5/2 doesn't make sense to the problem. It's not a reasonable answer. So 2.5 seconds is how long it would take the hickory nut to fall to the ground. Okay, so now you need to do the homework on the back, the worksheet on the back. It's going to practice these skills, and that will be due on Monday.